Hello everyone. We were discussing in the last class about the construction of the root locus and different examples we have considered. Now, in this lecture also, we are considering a special type of transfer function. That means open loop transfer function of any system is given like this form. Let's say the form you will see GSHS is equal to K into S plus A by S into S plus B. This is the structure of the transfer functions where mod of A is conditional given as greater than mod of B. So if this is the structure of open loop transfer function given, then the root locus, in this case the root locus is one circle. So this is a special case, right? If you find any transfer function given in this form, so definitely the root locus will be circle with minus a comma 0 is the center of the circle and root over a square minus ab is the radius of the circle, right? So we will analyze this thing that uh, if the transfer functions, if for example a transfer functions GSHS is given like k into s plus 2 by s into s plus 1. So by the similarity between these two functions, as this is a standard one, and you can see this modulus of a is equal to 2 and modulus of b is equal to 1. So this condition is satisfied. That means mod of a is greater than mod of b. If this condition is satisfied, then the root locus corresponding to this system will be one like a circle, right? And if this is a circle, and another condition is that the radius and circle center, so center is at minus a0. So minus a0 means minus 2 comma 0 will be a center. This is your 0 origin in this plane. This will be your real axis, this is your imaginary axis. So say this is your minus 2 point. So minus 2.0 is your center, and radius, what will be the radius of it? Radius will be 2 square minus 2 into 1, that means root 2. So 1.414. So this distance will be 1.414 and this distance will be 1.414. So if this value is minus 2, in the axis we say what is this value? This will be minus 2 minus 1.414, right? As this point is on the left side of the minus 2, so this distance is 1.414. See, so this value will be minus 3.414. And what is this value? This value is the right hand side of the minus 2. That means this will be something uh, greater than this. That means 1.414. So this will give you nearly 0.5. You see, so 6 like this, or 0.57 like this. So this will be the two values. One value is there and one value is there. So this will be the structure of the root locus. Now how it is actually we are getting, that we will see if the transfer function is like this, or we will start our example by considering this is as the example, that is the transfer functions, and we will follow this procedure, that this will definitely be a circle, and if this is circle, the center is expressed as minus a comma 0, and radius of the circle will be root over a square minus ab. Okay, so now we will start with this example. So start with our conventional procedure. That means this is open loop transfer functions. What will be the value of the open loop, number of open loop poles? So two number of open loop poles at s is equal to 0, at s is equal to minus 1, that we can get. Number 2 and m, here is a you see there is a 0. So what is the number of 0? One number of 0, that means s plus 2 equal to 0. That means s is equal to minus 2. At s is equal to minus 2, we will be having 1 0. So at s is equal to minus 2, there will be 1 0. Next step is that, so what is the number of branches available? So number of branches equal to number of open loop poles. So 2. there will be two branches which will originate from open loop poles. And number 3, n minus m, that is 2 minus 1. So one branch will terminate at infinity. So there will be two branches. One branch will terminate at infinity because n minus m number of branches terminates at infinity. So one is about this branch, and another branch, that means one branch will terminate at 0, that is at s is equal to minus 2. Okay, so terminations is fine. Now according to our next rule, what we should do in which root will they move. That means the angle of these asymptotes. First of all, we have to find out the asymptotic angles. What are the asymptotic angles we will find? See, we will take the same next step, that is your step 4, asymptotic angle. This is your phi a, that is 2q plus 1 into 180 degree divided by n minus m, where the value of q varies from 0, 1 up to n minus m minus 1. So in this case, n is 2 and m is 1. So this q will be having only, you see, 0 value, because n is 2, m is 1, this is 1, so 0. Once the value of q is 0, so only one asymptotic angle we will get, that is equal to 180 degree by, let's say, n minus m means 2 minus 1, that is 180 degree, right? So we get one asymptotic angle, one asymptote, single asymptote, 180 degree. And what is the purpose of this asymptote? Along, that means along 180 degree line, this pole will go to infinity, right? One pole will go to infinity and another pole which will go to 0. So that is the path already we will find out from the graph itself, right? So asymptotic angle, you see, once there is one asymptote, so there is no question of centroid, because centroid is the meeting point of all the asymptotes. If this is your centroid, for example, that means there is a asymptote, there is another asymptote, there may be another asymptote, and these all asymptotes are meeting at a point which is known as centroid. So as there is only one asymptote, so there is no question of centroid. So centroid is not required, right? So up to this we have completed certain calculations, and next what you have to find out? We have to find out, that means we have to just draw the structure in this time. Okay. So in the next step, what we will do, we will just plot all these poles and zeros on a S-plane set like this. This is your real axis, this is your imaginary axis, and we will draw here. See, the poles are at S is equal to 0. So at S is equal to 0 there is a pole, and this is your S is equal to 0, and you see this is S is equal to 0, where the value of K is equal to 0. That is open loop pole where the gain is 0. Next step, you can see this your S is equal to minus 1. See, this is S is equal to minus 1, and at S is equal to minus 1, we get the value of K is equal to 0. Fine. Next, there is a 0. 0 is indicated by circle. Already we know it. And this 0 is placed at S is equal to minus 2, right? So, the distance is here, you will see there is a 0. So, this is at S is equal to minus 2, where K is equal to infinity. Because wherever there is a 0 or infinity, we will get the value of K is equal to infinity. Now, this is one pole, this is one pole, and this is one 0 on the real axis. So once you get the poles and zeros on the real axis, what is the next step? Next step is to find out whether any part on the root locus branch exists on the real axis, or the part of the real axis which will be actually a branch of the root locus, right? So to do it, what is your procedure? That is the same procedure. You have to adopt the rightmost pole we are considering, and at the right hand side of this there is no pole or zero. So we have to move behind or the just left side of this pole. Okay. So considering this point, what is the right hand side total number of pole plus zeros? So total number of pole plus zero at the right hand side of this pole is equal to what? 1. So 1 means this is odd. So total number of poles at the right hand side of this pole is odd. Total number of pole plus 0, odd. Odd means there is a branch which will be existing between this right hand side of this point pole to the left hand side of this pole, odd 0. So this is a root locus branch, and see the branch exists here, right? And similarly you move on to the next point here at the left hand side of this pole, and you just try to find out what are the total number of pole plus 0 at the right hand side of this point. So total number of pole plus 0, here one pole and one pole, that means 2 in this case. 2 is even. So there is no branch exist between this point and this point, because this is the point under considerations, and right hand side of this is this pole, left hand side of this 0. So there is no branch exist between these two pole at zeros, right? And next move on to the left side here, and this point is actually close to infinity. Any point here you will consider as the infinity. So if this point is considered, and on the right hand side of this you see total number of pole plus 0, 1, 2, 3. Total number of pole plus 0 at the right hand side of this pole is 3, that is again odd. So you get right hand side of this point is this 0, and from this 0 to up to infinity there is a branch, right? You get branch here you will get the branch. Now the branch on the real axis has been considered, and we just come to know that there exists one branch and there exists one branch. And see, once the branch has been identified, next step is that you have to find out whether in this case the break away points or breaking point analysis is required or not, right? So we will go for the next step. So up to this we have calculated. Next step is that we have to find out the breakaway point analysis, right? So next is breakaway or breaking point determinations. It is required or not required, right? So to know whether the breakaway point is required or not, first of all what you have to do, you have to check whether any two side by side poles exist or not, right? Here you see this is one pole and this is one pole, and they are residing side by side on the real axis, and you would see this red color, that means or bold line, what you can do in your pencil, and you see this is a branch exist. So if there is a branch exists between the two poles which are staying side by side, so there is definitely breakaway point exist. And this breakaway point determination and breaking point determination is done with the help of the equations dkds equal to 0, as you know. So what you have to do, we have to get dkds is equal to 0. Solution of dkds is equal to 0 will give you the breakaway point. Now I'm going to give the detailed calculation of it, and again I will draw this structure. Okay, we will find the dkds, that means 1 plus gshs equal to 0. This is your characteristic equations, that means 1 plus k into s plus 2 by s into s plus 1 equal to 0. That means s square plus s plus ks plus 2 equal to 0. And from here you get k s equal to minus s square plus s plus 2, and k equal to minus s square plus s plus 2 by s, right? So this is your the value of k, or uh, sorry, this is ks plus 2k actually. So I have to rewrite this. It's written wrong, this structure. So actually k s plus 2 will be equal to minus s square plus s. So k will be equal to minus s square plus s by s plus 2, right? So k is obtained. Now you have to get the differentiation of it with respect to s. That means dk ds. So dk ds will be equal to your s plus 2. You see, s plus 2 square, s plus 2 into 2s plus 1 minus s square plus s into 1. Okay, so if this is your structure, then, and this is all minus, so from here you get dkd is equal to 0. I will have to make dkd is equal to 0. That means if I make the dkd is equal to 0, then what will you get? So dkds equal to 0 will give you s plus 2 into 2s plus 1 minus s square plus s equal to 0. Right, and you see this 2s square plus s plus 4s plus 2 minus s square minus s equal to 0, or this is s square, you see this is 2s plus 2 equal to 0. So after getting this is 4s plus, sorry, 4s. So this is s square plus 4s plus 2 equal to 0. And if you solve it, what will get? S is equal to minus 4 plus minus 16 minus 8 by 2. That means minus 4 plus minus root over 8 by 2. So 4 minus 2 plus minus 2 root 2 minus 4. So minus 2 plus minus root 2. These are the two values we get, right? So what are the two values we are getting? I will rewrite this structure here to analyze this problem. What is that? That means breakaway point, or we may call it the break-in point. What is that? S is equal to minus 2 plus root 2, and s is equal to minus 2 minus root 2. That means minus 2 plus 1.41, and s is equal to minus 2 minus 1.41. So this is near about minus 9.5 minus 0.59, rs is equal to minus 3.41. Okay, we are getting two values. You see, that means breakaway point and breaking point, and you see the structure is like this. That means k into s plus 2 by s into s plus 1, that is the structure of like this structure. So definitely we know this will be a circular structure. So Root Locus plot of this system will be circular in nature, and we are getting the breakaway point like this. And just we are writing the value here, that is minus 0.59 and minus 3.41, and removing all these steps to rewrite the Root Locus plot. So far we have developed the Root Locus plot is like this. This is your real axis, this is your imaginary axis. So at s is equal to 0, there was a pole. At s is equal to, you see, minus 1, so there was a pole. And minus 2, minus 3. At s is equal to, sorry, minus 3, there was a 0 with k is equal to infinity, k is equal to 0 and k is equal to 0. That much I know. And one thing another is that important part was that in between s is equal to 0 and s is equal to minus 1 there was a branch, and from s is equal to minus 3 to minus infinity there was again one branch, right? So once the branch has been identified, the thing is that you see the breakaway point minus 0.59. So either this will be valid or this will be valid. Here we are having minus 0.59. So minus 0.59 is lying somewhere between 0 and minus 1. Say this is the point. So we may call it as breakaway point, because according to definition two poles are lying side by side and there is a branch and we are getting one breakaway point. So this is s is equal to minus 0.59 and we are getting a breakaway point. And once this is a breakaway point, that means what? That means this pole is going towards this point, this pole is coming toward this point, they are leaving the real axis with an angle almost 90 degree. Okay, so this is moving like this. So branch has been moving like this. So we are getting, ultimately what you have to do, we have to get two poles, means two branches. So two branches, we develop two branches. One branch is going this direction, one branch is going this direction, right? Now where they will have to terminate, they will have to terminate either at open loop 0 or at infinity, right? So there is one open loop 0. So one branch may be terminating at open loop 0 and other branch must have to be terminated at infinity. And when this will go to infinity, see, this will go along but asymptote, and asymptotic angle is here 180 degree. That means the pole, the branch somehow has to come to this point, right? The branch has to come this point. Until unless the branch comes here, how this they will follow this path? Because this is the path 180 degree line through which this there is an asymptote, this will go to infinity. And similarly they will move, there is a single asymptote, and in order to reach to 0 they will have to follow only the real axis path. So this is the path through which, that means one branch will terminate at open loop 0 when the k will be infinity, and one branch have to be terminated to infinity with k is equal to infinity. That means you know the future of the two branches. Now these branches have to move to this point and see what will be the value where it will come in. That means this point is nothing but this point minus 3.41. Say this is minus 3. So this is your s is equal to minus 3.41 and this has to come here. That means two branches are coming here, right? And once they meet on the real axis and then they are moving toward 0. So this point is known as break-in point. So here this is the kind of problem where breakaway point and break-in point, both the points are actually existing. And once you are getting 2 points, that means this is the path, the locus, which will be, you know, the circle in nature, and the radius of the circle is what you see. The problem was this is s plus k into s plus, problem was s plus you know, this is your 2 by s into s plus 1, right? So this point was s plus 2, sorry, this is 2, s is equal to minus 2. So anyway, this minus 3.41 is far away from this minus 2 point. Now what is this? You see the radius of the circle, I have already calculated. Radius of the circle was, you see, what is the radius of the circle? Root 2, that is 1.414. This is the radius, and center was at -2, right? So center was at -2, and you see this was a circle having a radius 1.414. So center is just in these positions. If this is the positions center, so uh, how the this root locus branch will be actually, you see, the circle, right? So there is a point, if this is -2, definitely -3.14 is somewhere like this. And you see, if this is your center, so what happens, this is a kind of picture you are getting. I will just clearly draw the structure where you will understand. This is your center, and this is your radius, and this is your radius, right? Just I am trying to redraw the structure. See the clear picture here. You see, this is point is uh, s is equal to -0.59, which is known as breakaway point. Okay, so breakaway point means this pole is moving in this direction, this is moving this directions, and finally they are leaving this axis, right? Now what happens if this is your center? That means center of the circle is at -2. So -2 is the center, and radius, you see, radius of the circle is minus say √2, that is 1.41. So if this is 1.41, so definitely from the center this is -0.59. So this distance is 1.41, and similar to that, here in this side this will be 1.41, and that point you say this is -3.41, which is your actually break-in point. So break-in point means already we have developed that two branches are coming in this pot, and one branch is going to infinity with k is equal to infinity, and one branch is going to 0 to terminate at k is equal to infinity. Now see, this is 1.41, so this is breakaway point, and from the calculations this is -3.41. So breakaway point and breaking point occurs at the same time, and simultaneously you are getting the structure is like a circle. Okay, so you get the structure like this. That means a pole starts from here, this is moving towards this breakaway point, here it breaks or leaves the real axis, where one branch goes there and one branch goes in these directions, right? And these two branches are coming together and meet at a point on the real axis, that is known as your break-in point. And when it reaches the break-in point, the two branches again going to, one branch goes to 0 to terminate, and one branch goes to infinity along the asymptote, your asymptote, right? So this is the structure. That means if the system is like this, then that will be a root locus, and in that case you need not to find out the route array, because there is no chance of the root locus branch to move along the right hand side of the spline, where it will cross the imaginary axis. So this is the example where you can see both the breakaway points and break-in points exist simultaneously. Okay, and next class we will discuss a problem where you will see there is a kind of during the breakaway point determinations, if that is other than the second order functions, then how can we apply the numerical methods to solve to get the approximate value of the breakaway point. So breakaway point determinations for higher order polynomial. Okay, that I will discuss in the next class. Okay.